Now, you have the floor. You can unmute yourself now, okay? Try to unmute yourself.
Okay, Doctor. Good morning, and thank
Good
you
morning,
for
everybody.
the presentation as always.
You're welcome.
And so I just have maybe one or two questions.
Okay.
The first one is as regards to the randomization when we use percentage splits. Does WEKA does the randomization, or we'll have to do it before importing the data to WEKA? And maybe the secondly is not pertaining this class, is regards to attribute selection.
Okay.
There are many in the most common way of attribute selection that I've seen is using the correlation. But however, in WEKA, I've seen you can do it in multiple ways. So
Yeah.
like, is there something advisable? Okay, is this the best? You should use, you should not use the correlation. You can use some other things. And
Yeah.
what will tell you, okay, use this one in this case and then use another one in another case.
Okay, thank you very much. Yeah. Okay, for the first question, yeah, actually, once you load your data, the default partitioning that WEKA use is the randomized. It's randomized. Whenever you load the data into WEKA, it randomizes it and take the training set and the testing set out. This is the default setting in WEKA, except wanted otherwise. Yeah, because it's a very popular thing that we want the data we are using to be, we want our training set, the model to see training set that is representative of all the samples. So as you know that as you are getting sample from people, maybe you are getting sample from household to household, 3 people from this house, 3 people from another house. So if people, the first people you got data from, they're going to be from the same street. The other people will be from another street. So by the time we're going to do training, we don't want our system to see only sample from the same street. That's why randomization is very important. And it could be done from different parties, from different platforms, as the case may be. But for sure, the WEKA does that by default. Yeah, we partition your data by randomizing. First of all, randomizing and then partition the data for you. That is on regarding the data partitioning. So the other question is the issue of feature selection. Yeah, the issue of feature selection. Yeah, feature selection, there are many methods of feature selection, as you say, as you mentioned, actually. However, in WEKA, just like any platform you are using, Python, MATLAB, R, there's so many platforms you can run machine learning model, and that's something that is unique about machine learning. So it's not really language specific or a particular platform specific. And the good thing also is for researcher, no journal will ask you have to use a particular platform. No, make sure whatever platform you use, you make it very clear to them so that they can go to that platform and reproduce your result. Because some journals these days now, they are trying to do that just to ensure that to ensure integrity in the publication of machine learning based research. Now, as for which option is better, actually the attribute selection, as you can see here, this is select attribute. There are a lot of options you can have under the attribute selection. So method. So sometimes you might want to even consider evolutionary. This is, we can have different ones. We're going to talk about all this maybe later on. We talk about them. You want to the search, the best fit search, very simple search we use, but sometimes you might want to combine with evolutionary search, greedy step search, PSO, ranker, and so many other ones. However, this is the attribute selection option. You go here, you can see different ones. See, we have the classifier attribute evaluation. Here, you try to check the attributes. How are they contributing to the system? We have the classification subset. We have the gain ratio. We have the information gain attribute evaluation. This one is used by decision tree. So you can also use it. The same procedure decision tree use it. You can also use it for feature selection. The fact remains, this is wrapper subset selection. There are so many methods. Even this is not exhaustive, by the way. There are newer methods and so many methods of feature selection. However, when people start this correlation-based feature selection, I and a couple of my students actually started using it a few years ago when we had issue with a particular data set from oil and gas application permeability prediction. so many features, we try to improve the result. It's okay. Why don't we use correlation-based feature selection? Of course, it's been there before, but people usually ignore it because correlation looks a little bit simple. So people ignore it. They go for very complicated methods. And like I said in machine learning, the fact that you use complicated method doesn't guarantee you are going to get good results. Sometimes it's like using a big hammer to kill ant. If you're not careful, the ant might escape and you might end up even breaking your table. And this thing happened a lot in machine learning. People go for a very complicated method and they ended up not getting good results. So there's no guarantee that complicated method we get the result, the better result. So that's why we always recommend, we also mentioned in our earlier videos that we should try to start with simple methods. That is why for people just starting, I do recommend the correlation-based feature selection for them. This is very simple. You can do correlation in Excel environment, in any package. WEKA can also do it for you. Just say, okay, do the correlation and then run the experiment, arrange them in descending order. Let's say after you have done the correlation, this is the option A. You see? Yeah. So once you start it there, you can see here, it will rank your attribute for you. You see, it ran the attribute for you that number 3 on the list is having 0.66. This is the one with the highest correlation actually. Then it arranged it in descent of thing goes to near 0 there. So what we do we call something recursive feature elimination. So you try to select half of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Divided by 2, that's going to be 8. So select the best 8 from top and run the experiment. Then again, select the best half of that 8, that's going to be 4, another best 4, another best 2, until you get to, and then best 1, the first one there. This is called recursive feature elimination. You start from the complete feature, and recursively, you keep reducing it to half, until you get to 1. We've seen that even though because when you have very big features, there are also many methods like the exhaustive method. The best method is to try to check every 1 and 2. Run the experiment using only 1. Run it using 1 and 2 feature. Then remove 2 and put 3 there. Remove 3, put 4 there. And then so you do different combinations, exhaustive one. But when you have huge number of features, you can see that is not an option to try. You have like 50 something or even 100 and something features. And you want to do combination for everyone. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 3, 2, 6, 2, 7. You want to do that, try different combination. This is called exhaustive feature selection. For sure, you can get the best feature combination that's going to work for you. But however, the time complexity doesn't allow people to go for it. That's why there are so many other methods of feature selection. So if your feature is relatively big, go for this simple recursive feature elimination, do simple correlation, and then try to reduce the feature halfway by every experiment. After that, you are going to list out the result of each of the feature combination, and then you can be able to see which one is giving you better result. Of course, sometimes we might lose some information because, for example, now we are combining, we are assuming that the best correlated will give us better result. That's why we start with half. But sometimes, maybe if I compare this one, this 3 polyurea, if I combine it with this smallest one, etching, you see, because sometimes you have 2 features, if they come together, they can push the result up. But now we have eliminated them. That's why recursive feature elimination is assuming that those with highest correlation, they are always good together. But sometimes it's not the case. But maybe considered for our own case, our result always get better result when we use it compared to when we didn't use feature selection. We go for that. But that doesn't mean we have used the best feature selection. No. It's open for someone to pick any of those papers and try to check out, use different feature selection, maybe like all the 8 or 9 provided by WEKA or 10 or more, and compare your result with them. Maybe you are able to beat the result we got then because we use very simple recursive feature elimination. It's an opportunity for you to use other feature selection method and see maybe you get better result. That is why in machine learning, there's always room for you to provide improvement that you can report back to the research community as a way to always look out for when next they are going to select another machine learning project. So I hope I have answered your question. In summary, we are saying that there's no feature selection that is the best, but in line with machine learning principle, keep it simple. So start from very simple machine learning algorithm and machine learning feature selection, and then from there you keep moving on to more complicated one if you do until you get the best result. But if you use simple ones,
Yes, doctor. Thank you.
okay, thank you very much.
Thank you.
Barakallah.
The question has been answered very well. Thank you very much.
Okay, you're welcome. Thank you. So then Mr. Mohammed Balogun.
Assalamu alaikum.
Wa alaikum salam.
Alhamdulillah. Thank you, doctor, for the
You are welcome.
vast explanation.
Yeah,
Yes, I just want to ask about WEKA actually.
okay.
Does WEKA provide all the data we are bringing into WEKA? Does WEKA have a way we can clean the data? All the data must have been cleaned before we bring it in.
Okay, yeah, thank you for that. It depends on the kind of the WEKA actually is one of the platform that your raw data, even when you have missing value, you can run your data in WEKA, even without treating missing values. You can run your data in WEKA. It's one of the very, very powerful, sophisticated area that you don't want to waste time on cleaning. I mean, missing value treatment, outlier, whatever, especially missing value. Some programming languages for machine learning will not work if you have missing value, but for WEKA, no. WEKA has that capability to run your experiment even when you have missing value. Yeah, so you have missing value. However, it's good to do some of these things before importing your data to the WEKA environment. Yeah, so when there are so many other, this is where, because sometimes this is where the programming stuff comes in. So that, okay, if somebody maybe there are some programming, there's some programming kind of script that are used for some of these particular purpose, like missing value, outlier detection, so easily run. And there are some other packages also that could be used to support your pre-processing before you actually bring them in to the WEKA environment. So that, but WEKA allows you to run your data even without any cleaning. It can run for you, even while other platforms will not allow you to run your data without treating missing value, for example. I know some packages, if the missing value there, you cannot run them. Let's say like maybe MATLAB environment. I've used that a lot before. So they will not allow you to run with the presence of missing value. You have to first of all treat it. But WEKA allows you to do that. However, for WEKA, it's expecting you want to do, because it allows you to do missing value, the capability to come inside there and come and do so, you have to do it outside the WEKA environment. Thank you. Okay, then Mr. Abdullah.
Yes, assalamu alaikum, doctor. Thank you for a wonderful lecture.
Okay, you're welcome.
Yeah, I just wanted to ask actually about the applications that we would be using. So just an example, for example, in healthcare, let's say, where would you see using this method, or one of the methods we discussed in application of healthcare? Something coming to mind into that field?
Okay, Mr. Abdullah, sorry. Okay, can you come up with your question again? Sorry for that. So can you come again, please?
Yeah, just asking about applications of
okay.
Yes, yeah.
Yeah. Okay. Yeah, we actually we are in the series of trying to discussing different application of machine learning in different fields. So we've discussed several in the past, so looking at different things, and we are still all going with it. Hopefully by next week we are going to start another paper presentation where we are going to pick one of our work and then we go to demonstrate and discuss and now demonstrate how we actually accomplish such tasks, actually. Real-life application of AI or machine learning in solving real-life problems. So, for example, last time we discussed, I remember how we use machine learning to predict anxiety during COVID-19. So we want to predict if somebody is having anxiety, suffering from anxiety as early as possible before it goes out of hand. So we also discussed the other one that followed was Alzheimer's disease. So people can preemptively diagnose the presence of a particular disease before the disease actually come into full force, before symptoms start coming out. So we try to use machine learning to identify and to diagnose. So we discussed some of this. You can actually refer to our videos. All these the videos are uploaded in our YouTube channel. So we can refer to that. And inshallah, others actually are coming in that particular direction. And also, we also have the PowerPoint presentation that we use when we are discussing different types of applications. So we can use, and I think we share with us. If you need it, you can also let me know. I can also share those PowerPoint presentation that describes some of the possible areas we can actually beam our light on in trying to apply machine learning to our everyday machine learning to everyday healthcare problem solving scheme. So
Thank you.
so
Thank you.
you are welcome, Mr. Abdullah. So I know you work in the medical area, so you are highly welcome to the forum, and I hope you're going to have opportunity to benefit from the series.
Yeah.
Thank you very much and welcome.
Yeah, thank you.
Now, Dr. Bashir, are you available now? You have the floor before we end it for the day.
Assalamu alaikum.
Wa alaikum salam.
Okay, yeah. Jazakumullah khairan. My question is, today's class is on how to partition using WEKA.
Yeah.
And from the explanation, I can understand that we will partition depend on the fold. If we are using two fold, we will partition divide based on percentage. But there is no part. I mean, throughout the class, there is nowhere you mention which algorithm we are going to use. I mean, are we not going to select the algorithm? Is it the WEKA that we select the model or the algorithm that will do the that we are going to use?
Okay, thank you very much. I got your question. So maybe you missed that aspect. Actually, we did that. So because the first thing, as you can see my screen, is to bring in your data. Once you open and load your data set, the next thing is you go to classify. I now said today we actually focus on how to partition data, because we assume that we already know how to select the algorithm. And we still actually selected one algorithm as an example for us. So this is where we work today, how to partition. If it is cross validation, just state the number of folds. If it is percentage split using only two partitions, you have this option. And if you have to use 3 partitions, you have to combine this with supplied test data. I said these are the 3 ways by which we partition data in building model in WEKA. Now, and now say, okay, to demonstrate, you have here, we can choose our model here. So we have to choose the model here. So now say, okay, let us choose our very simple model under the lazy classifier. We have the IBK, the K nearest neighbor, which is a very simple example for everybody to remember. We also have the meta model. We have the meta model, the ensemble, and also for that. But usually I say you keep things simple. That's why we always like to use IBK. It is when IBK fail, decision tree fail, then we go to more complicated system. Now, so we mentioned that, so how to select, this is where you select a particular which algorithm you want. Meanwhile, also let me add that WEKA has what we call auto WEKA. You see, auto WEKA means if personally I don't use it and I don't recommend it, because sometimes you spend a lot of time and ended up recommending what might not work. So auto WEKA is if you have a new data set, you just want to check, Just upload your data and go to WEKA and set it up. It will run several experiments for you. And if it will run several experiments using different machine learning algorithms, keep selecting them at random as it goes, and then put your result in Excel for you. You can now go and check your result, which classifier is likely going to work for me on this new data set. You see, it has that capability. But personally, I don't use that. I like to, based on the experience I've gotten, I should be able to know how to start simple. And if it fails, I should be able to know when to go for more sophisticated algorithm. But for newcomer who want to try WEKA, you want WEKA to select for you, just go to WEKA, you upload your result, just start it to start running. It can run for days, depending on the kind of machine you are having, because try to run as many algorithms as possible and then tell you the result. And so you can, of course, it's going to be using default value. That's why personally, I don't use it, because the power of hyperparameter optimization system is very important. A simple algorithm like K nearest neighbor can get me very excellent result if I do appropriate hyperparameter optimization. So that is why I see that's waste of my time going to WEKA that we run using default value for so many algorithms. At the end of the day, you have to see, okay, which one is get better results. I will now select it and try to optimize that one. But the fact remains, the fact that you are now optimizing the one that gave default better result with default value doesn't mean that other that gave low default value result cannot get better result better than this, because optimizing parameter is very important. So, but it's another option for people who want to try it out. But for me, I don't use it. I prefer to go systematically as we have described, get my data, try to do the parameter optimization, do feature selection if necessary, and then report my result. Thank you very much. I hope I answer your question, Dr.
Naam, you did. Jazakallah khair.
Barakallah feek. Thank you very much, everybody. So I think that's the question we have for the day. And thank you for the coming. I wish you all the best and the engagement. Feel free if you need any further clarification, it is not clear, feel free to engage with us, communicate. I wish you all the best. Thank you. Until next time when we go to meet, thank you very much. Assalamu alaikum.